This is R.D. Sharma Solution, Class 12, Chapter 14, Differentials, Errors and Approximation. Exercise is 14.1. If there is an error of 0.1% in the measurement of radius of a sphere, this is the sphere we are talking about. Find approximately the percentage error in the calculation of the volume of the sphere. Now this R is X we are assuming, radius, and volume we are assuming as Y. Now the question is saying delta X by X into 100, that is the percentage error in the radius, is 0.1. Now you know that delta X we have to equate it or is nearly equal to dx, delta y is nearly equal to dy. So dx by x into 100, let us take it in the denominator. It's 1 by 1000 because 0.1 is 1 by 10. So dx by x is 1 by 10,000 or 1000. Okay. Now we have y equals 4 by 3 pi r cube, that is pi x cube. Let us take dy by dx here. What do we get? This is 4 pi x square, then this is 4 by 3 pi r cube. So x cube, when you differentiate, 3 gets cancelled, 4 pi x square will come. Now dx by x. Now let us bring it here, dx, and this is, if we are introducing x, we have to have x in the numerator. So x cube I am writing because we have introduced this x by ourselves. Now if you divide it by 3, you have to multiply it by 3. Why I did this? Because 4 by 3 pi r cube or pi x cube is y. So this y you can bring down here. So it will be 3 into dx by x. So dx by x is what? 1 by 1000. So 3 by 1000. That is, we have to find out the percentage. So delta y by y into 100. This you can assume it to be multiplication by 100. So this goes 2 zeros. 3 by 10 is 0.3. So 0.3% change in the volume will be the result. So how we are going to do this? This is the logic I told you, and you have to write it like this, exactly like this, right? The pressure P and the volume V of a gas are connected by the relation PV to the power 1.4 equals to constant. Find the percentage error in P corresponding to decrease of 1 by 2% in V. So you have delta X, delta Y, that is delta X is known, delta Y we have to find out. So what is to be computed, we always assume it to be y. So P is y, and we know that 0.5%, so we take x as v. Now let us come to the relationship which is given. PV to the power 1.4 is equal to k. K is some constant. Now in order to solve this, let us take the log on both the sides. Log a into b is log a plus log b, and log x to the power y is y log x. That is what we are going to deal. Log p 1.4 will come in front. Log v is going to be on the right, it's log k. Now let us differentiate. We always differentiate with the value which we know. So we are differentiating with respect to x. That is v we are differentiating. So 1 by p and then dp by dv, because p has to be, because we are differentiating with respect to v, plus 1.4 log v is 1 by v. Nothing will come here, nothing will come here. And log k is a constant, so the differential will be 0. So now bring these dp by p equals, when you take it on the right hand side, it is negative 1.4 by v, this dv goes up. Remember, we have to find out dp by p, that is dy by y. Find the percentage error in p corresponding to decrease of 0.5% in v. So the percentage error delta v by v into 100 is already given as half percent. So this dv by v, if we multiply both sides by 100, dv by v into 100 is half, and on the left you will get the percentage change in the pressure. This whole is going to be half, this one, and since it is decreasing, see, it is the answer to be positive, we have to write negative in place of decrease. So you have minus 1.4 into minus half. Let us multiply this. Minus become plus. 1.4 divided by 2 is going to be 0.7. So dp by p into 100 is 0.7. Basically it's delta y by y into 100 only, because delta x by x into 100 is given as negative half percent. And how are you going to do this? Let me just clean it up so that you actually see how you have to write, because my handwriting is real good. You have to follow these instructions and you have to write everything in language. The height of a cone increased by k%. Its semi-vertical angle remaining the same. So semi-vertical angle, when it remains the same, there are things which we have to understand here. This is a triangle, and the angle which I'm talking about is this one. You have height, slant height, and the radius. So when the angle remains the same, the ratio in which the height and radius and slant height will increase or decrease will be equal. That is delta h by h into 100, that is the percentage change in the height, will be equal to the percentage change in the radius will be equal to the percentage change in the slant height. So delta L by L into 100 is equal to delta R by R into 100. Okay, this is the very important part of this question. Let us assume it to be some k. Now the height of the cone increases by k%. So you can assume k as some c or something, right? Now this is the t. T is the total surface area. These are the two areas you have to add. Pi RL is the total one, and the around one and the base one is pi r square. So dt by dr is pi, and r dl by, I'm using the product rule for r and l. So r dl by dr plus l, we are differentiating with respect to r, so it will vanish. And this becomes 2 pi r because r square differentiation is 2r, 2 pi r. So what do we get? Now this pi r dl by dr plus pi l plus 2 pi r. Now you already know dl is delta L, dr is delta r, and that is equal to the ratio of L by r. So delta d and L, they are all can be equated and change interchangeably. So pi r, here I'm writing L by r plus pi L plus 2 pi r. You can cancel these two. Pi L plus pi L is 2 pi L. This is 2 pi L. You have 2 pi r here. So 2 pi L plus r is dt by dr. Now dt here and dr, this dt by dr we have got. I'm taking dr on the right hand side. Now dividing it by t, that is the total surface area, you can divide this pi r. If you take this pi r common, you get pi r L plus r. So you have pi r L plus r, and now you have this see, there is a r. I'm bringing it down with your dr by r. So I'm just removing it. Dr by r. L plus r cancel, pi gets cancelled. So finally you get dt by t. If you multiply by 100 also, dt by t into 100 is equal to twice of, this is twice of percentage change in total surface area is in the left. 2 dr by r is what? In place of dr by r, the first thing I told you, so you can replace it by delta h by h into 100. Alright. So delta h by h into 100 can be easily replaced by dr by r into 100. So you have k% as the answer here, k%. So this k multiplied by 2k is the final answer. So the percentage increase in the total surface area is 2k%. So let me just show you how we have done this. This is the total thing. Okay, I explained you how I approached it, but you have to write it like this. Now same thing will be done with the volume. So volume is what? 1 by 3 pi r square h. This is the volume. So dv by dh is 1 by 3 pi. Now by product rule, let us differentiate it. R square, then differentiation of h is h, then h, differentiation of r square is 2r, dr by dh. I told you dr by dh can be written as r by h. So just write r by h in this case. H gets cancelled, you have 2r square here. 2r square plus r square is 3r square. So you have 3r square into pi by 3. 3 gets cancelled, dv by dh is simply pi r square s. This is dv by dh is pi r square. Now take this dh on the right hand side. So you get dv as pi r square into dh. Now just make it the way we are fond of making it, as a percentage error. dv by v, so you have to multiply v. If you are multiplying v here or dividing v here, you have to have a v here also. And then you have to have a h, so you have to have an h in the numerator also. That is because we want dh by h. So a h has to be in the numerator also. Okay. So pi r square h in the numerator, and volume is 4 by 3 pi r 1 by 3 pi r square h. So we have dh by h. So this pi r square h cancel. This 3 goes up, so you have 3 dh by h. So dv by v is 3 dh by h. Multiply both sides by 100. This is delta v only. This is delta h only. Okay, just multiply it by 100. So you get thrice of it. And you already know delta h by h into 100 is already given in the question as k%. So you can just take this 3k% is the answer. The percentage increase in the volume of cone is 3k%. Show that the relative error in computing the volume of a sphere due to an error in measuring the radius, this is we are talking about, is approximately equal to 3 times the relative error in the radius. So the previous question was quite tricky, but this is quite easy. If you have done that, it will be easier for you. Volume is 4 by 3 pi r cube. I'm taking radius as x, and what we don't know, v, so we take v as y. Finally, you can write it as y equals 4 by 3 pi x cube. Now just differentiate. Dy by dx is 4 by 3 pi. This is 3x square, and you can cancel this. 4 pi x square. This is dx, bringing it on the right hand side. So we have dy. Now this dy is delta y. This is 4 pi x square. Dx is delta x. Now divided by x into 100. So you have to have x in the numerator also. See, I have introduced an x in the denominator, so I have to multiply x in the numerator. Delta by x into 100. So if you have multiplied 100 here, you have to multiply 100 on the left hand side also. And as I have x in the denominator, I have to have a x in the numerator. Here also, if we have y in the denominator, you have to have the y in the right hand side also. But v is what? Y is what? It is 4 by 3 pi x cube. Okay, this is volume only. Y was volume only. Now you can just cancel things out. You get 3 in the denominator. It goes up because it is reciprocal. So y% is equal to thrice of x%, because delta x by x into 100 is x%. So you can just write it as y% is equal to 3 times x%. This is the answer. Okay, they wanted to prove. We proved it. Okay, this is a series of questions. Many questions are there of this type. So we'll take it in the next discussion. Till then, thank you so much. Take care of yourself.